Don't forget to subscribe to our channel for more videos, and press the bell icon to receive updates.
Hello friends, in this video we shall study the meaning of deformation in the body and classification of materials on the basis of their response to the deforming force. Now let us study effects of applied force on a body. Let us consider the first possibility. If the force acting on a body are unbalanced, that is the resultant force acting on the body is not zero, then the body is set into translation motion. Consider the first figure. Body is acted upon by the force of 5 Newton towards right. It is unbalanced force. Hence, body will move towards right. Thus, an unbalanced force causes a translation motion in a body. Now, let us consider the second possibility. If the forces acting on the body are balanced, but the net movement is not zero, that is, the resultant force acting on the body is zero, but the resultant movement is not zero, then the body is set into rotational motion. In this figure, there are two equal and opposite forces, each of magnitude 3 Newton, and they are acting on a bar. As the two forces are equal and opposite, the net force acting on the body is zero. Hence, there is no translation motion in the body. But if you observe carefully, you can find that the lines of actions of two forces are different. Hence, torque is produced in the body, and due to which body will start rotating about an axis passing through its center O and perpendicular to the screen. Thus, if two equal and opposite forces act on a body and their lines of actions are different, then the body is set into rotational motion. Now let us consider the third possibility. If the forces on the body are balanced and there is no net magnetic moment acting on the body, then the force may produce change in size, shape, or both in the body. In this figure, two equal and opposite forces are acting on the body and their lines of actions are one and the same. Hence, net force acting on the body is zero and the net movement of the force is also zero. Hence, there is no translational motion and no rotational motion in the body. In such a case, force may produce a change in size, shape, or both in the body. In chapter Elasticity, we shall consider the third case, where there is no motion, but there is a change in size, shape, or both of the body. Now, let us understand the concept of deformation and deforming force. The force applied to a body can produce a change in shape or size or both. Such a change is called deformation. The forces which produce deformation in the body are called deforming forces. In the diagram, we can see that on the application of forces on the body, there is a change in the shape of the body. As the force applied is the deforming force. Now let us study characteristics of deformation. The extent of deformation is always directly proportional to the deforming force. Thus, more the deforming force, more is the deformation. Similarly, less the deforming force, less is the deformation. Due to deforming force, the length of the wire or volume of the body or shape of the body changes. Thus, deforming force is capable of changing dimensions of the body on which it acts. When deformation takes place, the body is said to be strained or in the deformed state. In this strained state, the body possesses potential energy called strain energy. Whenever deforming force is applied on the body, internal restoring forces are introduced inside the body, which oppose the deformation. These forces try to bring back the body to its original shape and size. The applied force is numerically equal to the internal elastic restoring force within the body, but in the opposite direction. It means if the deforming force tries to decrease the size of the body, then the internal restoring force will try to increase the size of the body and vice versa. Deformation produced in the body is due to change in the relative positions of the molecule within the body due to applied deforming force. Due to the change in the relative positions of the molecules of the body, there is a change in the size or shape of the body. Now let us study the classification of materials on the basis of deformation. Every engineering structure is subjected to external loading of various kinds like normal loading, shear loading, or mixed loading such as bending, torsion, etc. When substantial load is applied on the material, it tends to deform. Depending upon the response of the material towards the deforming force, the materials are classified into three types: elastic material, plastic material, and rigid material. Corresponding material properties are elasticity, plasticity, and rigidity respectively. Now let us study the concept of elasticity. The property by virtue of which material bodies regain their original dimensions, size, shape, or both after removal of deforming force is called elasticity. The material exhibiting elasticity is called elastic material, and the body is called the elastic body. Example: rubber, steel, aluminium, copper, etc. When you apply deforming force on a body, its shape changes. And when you remove the deforming force on the body regains its original shape and size. Then the body is said to be elastic body. Material of the body is called elastic material, and the property itself is called elasticity. In the diagram, a body is subjected to deforming forces. The shape of the body is changing, and when the deforming forces are removed, body is regaining its original shape. Hence, the body is elastic body, and a property is called elasticity. Now, let us understand what is meant by perfectly elastic body. A body which regains its exact original shape and size immediately after removal of the deforming force is called perfectly elastic body. There is no perfectly elastic body, but quartz and phosphor bronze are the examples of nearly perfectly elastic bodies. Now let us discuss factors on which the extent of elastic behavior depends. For given stress, the strain produced in a steel is very less compared to that produced in rubber. Hence, the value of Young's modulus of elasticity is more for steel than that of a rubber. Hence, we can conclude that elastic behavior of the material increases with the increase in the value of Young's modulus of the material. There are two types of elasticity, shape elasticity and volume elasticity. As solids have a definite shape and definite volume, therefore they alone possess elasticity of shape as well as volume. Liquids and gases have definite volume but an indefinite shape. Hence, they possess volume elasticity only. Now, let us study the characteristics of elasticity. Elasticity is the property by virtue of which material bodies regain their original dimensions, size, shape, or both after removal of deforming force. This is the defining character of an elastic body. When the body is stretched, the interatomic spacing increases, and when it is compressed, the interatomic spacing decreases. In both cases, internal restoring forces are created in the body which tend to restore the atoms back to their original positions. In the first figure, a mass is fixed to one end of the spring and other end is fixed to a rigid wall. The spring represents the interparticle forces. In equilibrium, the length of the spring is L0. Now consider the second figure. When the mass is pulled away from the wall, the spring is stretched. The length of the spring increases, thus restoring forces are produced in the spring, and they will try to bring back the mass to the original or equilibrium position to decrease the length to L0 again. When we release the mass, the restoring force brings back the mass to the equilibrium position. Now consider the third figure. When the mass is pushed towards the wall, the spring is compressed. The length of the spring decreases, and as restoring forces are produced in the spring, and they will try to bring back the mass to the original or equilibrium position and to increase the length to L0 again. When we release the mass, the restoring force brings back the mass to the equilibrium position. The deforming force required for elastic body is small, and the amount of elastic deformation is very, very small. Within elastic limit, the Hooke's law is applicable. The Hooke's law states that within elastic limit, the stress produced in the body is proportional to the corresponding strain produced in the body. Within the elastic limit, the stress strain graph is straight line. Elastic limit is the maximum stress below which, if unloading is done, body regains its original shape almost completely. During deformation, a work is done against the internal restoring force. Hence, potential energy is stored in the body. Energy absorbed by the material during elastic deformation is called a module of resilience. Elastic deformation occurs before plastic deformation. Thus, without elastic deformation, plastic deformation is not possible. Due to deformation, there is no change in chemical properties of the material of the body. Hence, the mechanical and metallurgical properties of the solid material remains unaltered even after deformation. Elasticity is an important concept of physics and used in designing mechanical and civil structures, frames, and equipments. It is the foundation of the subjects like strength of material, mechanics of structures, designs of structures, and machine design, which we have to study in engineering. The second type of material on the basis of the response to the deforming force are plastic materials, and the corresponding property is called plasticity. When a body is acted upon by deforming forces and shape and or size of the body changes, but if the deforming forces are removed, the body retains its new shape and size. Such body is called plastic body, and the property is called plasticity. Example, plaster of Paris, clay, mud, plastic, etc. In the diagram, a body is subjected to deforming forces. The shape of the body changes. And when the deforming forces are removed, the body retains its new shape. Hence, the body is a plastic body, and a property is called plasticity. In plastic bodies, no internal elastic forces or restoring forces are produced. And if produced, they are negligible. Hence, they cannot regain original shape, but in the absence of restoring force, they retain their new shape. Now, let us understand the concept of perfectly plastic material. If a body has no tendency at all to regain its shape and size when deforming force is removed, it is called perfectly plastic body. No body in the universe is a perfectly plastic body. Wall putty and paraffin wax can be considered as a perfectly plastic body. Now, let us study characteristics of plasticity. Plasticity is the property by virtue of which material bodies retain their new dimensions, size, shape, or both, even after removal of deforming force. It is defining character of plastic body. When the body is stretched, the interatomic spacing increases, and when it is compressed, the interatomic spacing decreases. In both cases, internally restoring forces are created, in the body, which tends to restore the atoms back to their original positions. Due to no or negligible internal elastic or restoring force, plastic bodies cannot regain their original shape but retain their new shape. In case of plastic bodies, the deforming force required is large and the amount of elastic deformation is very large. Hooke's law is not applicable to plastic bodies. In the plastic region, the stress strain graph is non-linear. The total energy absorbed by the material during the elastic or plastic deformation region is called module of toughness. Plastic deformation occurs only after the elastic deformation. Many properties of the solid material change after plastic deformation. Concept of plasticity is important in sheet metal working, molding, rolling, forging, riveting, etc. The third type of materials on the basis of their response to the reforming force are rigid materials, and a corresponding property is called rigidity. When a body is acted upon by deforming forces, and however it may be large, there is no change in the shape and size of the body, then such a body is called rigid body, and a property is known as rigidity. In rigid bodies, the internal force of attraction is so high that there is no relative motion between two particles of the body. Hence, there is no change in the shape of the body. In figure, we can see that even after applying large force, the shape of the body is not changing. Thus, the body is rigid body and the property is rigidity. In practice, it is not possible for us to get perfectly rigid body, but large blocks of metals, stones can be considered as rigid bodies. Now let us study characteristics of rigidity. When a body is acted upon by deforming forces, and however it may be large, there is no change in the shape and the size of the rigid body. It is defining character of rigid body. In this case, the distances between the constituent particles do not change. Thus, there is no relative motion of particles on the action of deforming forces. However, maybe large force is applied, there is no change in the shape of the body. As there is no strain in the rigid body, Hooke's law is not applicable. As there is no change in the shape of a rigid body, no energy of deformation is stored in it. There is only a stress in rigid material, but no strain. Now let us conclude the information we have studied. Depending upon the response to the deforming force, materials are classified into three categories. Elastic materials, example rubber, steel, aluminum, copper. Second is plastic materials, example plaster of Paris, Dow, PVC. Third is rigid materials, example large metal blocks. And the corresponding properties are elasticity, plasticity, and rigidity, respectively. Thank you for watching this video. In the next video, let us understand the concept of longitudinal stress, longitudinal strain, Hooke's law, and Young's modulus of elasticity.
Don't forget to subscribe to our channel for more videos, and press the bell icon to receive updates.